Or I present, or I start directly?
No, you can start.
Okay, so hello everybody, thank you for being here. So I'm gonna present the two speakers of today. Victor Lefèvre is PhD candidate in philosophy at the University Paris 1 Panthéon-Sorbonne and professor of philosophy at the high school level. His thesis is entitled Ecosystems, Quasi-Organisms, the Power of Ecological Organicism. The aim of his thesis is to make the history of this idea, to evaluate its scientific fruitfulness, and to draw ethical, practical consequences from it. His talk of today is entitled Some Arguments for the Monetization and Against the Commodification of Ecosystem Services. Antoine Dolez holds a PhD in sociology from Grenoble-Alpes University. His PhD thesis was entitled Knowing and Managing Forests, Anticipating Their Futures, investigation into French forest research infrastructures, and examines both from a sociological and historical perspective how French forest futures are shaped. Following the SDS approach, his work draws on the concept of forest research infrastructures to describe and understand how forests are transformed into numbers and data, and how they are quantified, modeled, and computer simulated to be managed and governed. He is currently postdoctoral fellow at the Somme Institute, at the Mesopolis Laboratory of Aix-Marseille University, and at the PAMBLE. He is now studying a foresight exercise, MED 2050, that aims to create scenarios on the future of the Mediterranean area. He also has initiated a research group in social sciences focusing on foresight and futures. His talk of today is entitled Three Visions of the Futures of Forests in a Changing Climate, the Epistemic Commitments of Forest Scientists. So, Victor, if you're ready, you can go.
Yes. First, I would like to thank Pablo and Fabrizio because the talk has been deleted because of me. I would thank you for the date, for the changing the date. And just to explain where I come from, I'm a philosopher, teacher, and PhD. So I will speak today about scientific and economic subjects without a strong background on the details of the study I will speak today. And my PhD dissertation is about the idea of ecological organisms, the idea that ecosystems are organized like organisms are. So basically, the idea that there is a development of ecosystems, we can have natural selections of ecosystem on these kinds of idea. On my dissertation is in part historical. I made the history of this kind of idea, and I try to evaluate the scientific value of these ideas. And the final step is to make some practical and ethical arguments. So today I will speak only on this part that is less elaborated of my work. So it's just I try to put together some ideas, and it's not very well how to say it's not a very good demonstration. It's just it's kind of work in progress. So as everyone knows, nowadays humanities face an urgent ecological crisis, and some economists believe that one of the cause of the ecological crisis is the fact that ecosystem degradations is not taken account by economics. The idea is what has no price has no value. So there is a whole field of research dedicated to assess the economic value of ecosystem services. It's what we call environmental ecology. And from the work of environmental economists, there is a political project to create some markets of nature assets, and some people are deploying this kind of projects. whose officially aim to rationalize the use of nature. The idea is that if we put a price on some natural goods, and if we make a commodification of these goods, there will be a more efficient use. So this is a general idea. And if we speak in technical economical terms, the idea is to internalize what we call the negative externalities of some activities. Some activities, for example, degrade some kind of ecosystems. The most famous case is the production of CO2. And if we put a price on this production, and we make the people who produce the industry who produce this, if we oblige them to pay for this, they will lower their emission. This is a general idea. And there is a strong political opposition to this political agenda. What is kind of strong is both non-governmental organization is against, and both government doesn't really care about this. So what I want to do today is, my talk will be in 3 parts, but what I want to do is to criticize these projects not on a political base. I want to show you that it is either technically unfeasible, it's impossible to build efficient markets with natural assets, or if it's possible, it's morally reprehensible. So it's not only pure ethical arguments, it's also an argument on the practical aspect. Is it possible to have an efficient market with natural assets? And my talk will be in 3 parts. First, I will explain you the idea of monetization of ecosystem services. Secondly, I will show you how it works, how it's possible to put a price on some ecological activity. And in the third part, I want to address the question why we will do this. And it's not only for commodification. So this is the outline. And I think the first step is to explain what is an ecosystem. So historically, the concept of ecosystem has been coined, the word has been coined by Arthur Tonsley, a Britannic ecologue. And this is the first definition of ecosystem. I will just read it quickly. An ecosystem, it's not exactly a definition, but the definition is inside this quoting. So the more fundamental conception is, as it seems to me, the world system, the more fundamental conception for ecological units is, as it seems to me, the world system in the sense of physics, including not only the organism complex, but also the world complex of physical factors forming what we call the environment of the biome, the habitat factors in the widest sense. So the idea is, before Tonsley, people in ecologists, studies organisms and their interactions with an environment. And what said Tonsley is that the system should not, the system that we studies is not the population of organisms, but it's a world system made both by organicists and what we call abiotic factors. And what is very interesting in this definition is the part in how we said brackets in the sense of physics. The word ecosystem is based on the idea of system in physics. It's a shift from a purely biological work to some things, to a new kind of study who use the theoretical tools of physics. And just to be more clear, so the idea is just that ecosystems are the most fundamental units of ecology, and Tonsley said we should study them with physical theory. So I can give you now more recent, maybe more clear definition of what is an ecosystem. It's from more recent paper. The author says that an ecosystem is a set of species in a given place on all the interactions that they have with each other and with the environments, on all of the flows of matter and energies across species and their environment. And you see there is physics aspects when we said we studies the flows of matter and energy. So in nature, what we have is this lake, forest, and mountain, and atoll. And to do ecosystem ecology is when you have this to see this, to make some measurements of the flow of energy in each compartment. For example, you have the predators, and when you do ecosystem ecology, you make a measurement of the flow of energy that come from primary consumers to the secondary consumers, which are predators. On ecology, ecosystem ecology, there is we can say that the project of Tonsley have been a success in the sense that ecosystem ecologists have succeeded to produce some law, to discover some law, some regularities in the functioning of ecosystems. So I just give you, because I'm come from philosophy, a famous quote from Kant, who says that there is only science when we have genuine science, when we have mathematics inside. This can be criticized, but it's clearly the case that ecosystem ecology succeed to make a mathematization that many other parts of biology have not yet succeed to do. For example, you have a very simple law that says that at each level you have a decreased productivity. The productivity of herbivores are better than the productivities of predators, and top predators have the worst productivity than first predators, and so on. But you have a better efficiency. There is less energy, we produce less at each level, so there is a better use of energy at each step of the trophic chain. Ask me a question if I'm not clear. I'm sorry if I go very quick. I don't know if this is obvious stuff for everyone, or if I'm talking some kind of Chinese. Just tell me.
No, go ahead.
Yes. So to do ecology is basically to do this kind of schema on studies. This is the evolution of the production of a forest according time, and there is a lot of studies about many kinds of ecosystems. I think this was important preliminary to have a good understanding of what we talk about when we talk about ecosystems. Of course, we can make a full talk what is an ecosystem. What I said, it can be criticized in many ways, but I don't want to make a philosophy of science talk. It's just some preliminary information to understand what will follow. So if you want to make a monetary evaluation of ecosystem services, you have first to have a concept of ecosystem, of course, but also to have a concept of ecosystem services. So basically, as the name suggests, an ecosystem service is a service provided by an ecosystem to humanity or to some group of humans. But what is interesting is that a classification of ecosystem services has been made mainly in a big science project called the Millennium Ecosystem Assessment. It was a very big project with thousands of researchers, and it's a project in big part launched by the organization of United Nations organization. So it's a very big project with UNESCO and many universities like Cambridge, Oxford, and so on. And they produce a lot of reports. On one of the first reports, just explain the project. It's very elaborated theory. I will just give you the main stuff. Sorry, my some of my slides are in French because I didn't take enough time to translate. But basically, the Millennium Ecosystem Assessment distinguish four kind of ecosystem services. What they call, I think I have the English here, the supporting services. Supporting services is just no, this is not supporting. I didn't put in the good order, but supporting services is all that allow life to exist. But for example, very simply, the soil formation or the existence of water, drinkable water on Earth, or this kind of stuff. There is what they call provisioning services. This is basically the natural production. We go directly in human consumption. For example, wood and all the meat that we take from ocean and so on. So they give it here food, fuel, and so on. It's what nature produce and we directly use, natural resources. What is interesting is the two other kinds that are not obvious, what they call regulating services, and they give many examples like climate regulation and disease regulation. And there is a very odd four kind of ecosystem services. Is the cultural ones. Is what they put is aesthetic, spiritual, educational, recreational services. A very simple example: if you have a forest, the forest is useful to produce wood, but is also useful because people go inside the forest and enjoy the forest, have an recreational pleasure, as they said. And before to go to the cultural services, I just want to put a very interesting aspects. We speak a lot about climate regulation, but in the report, there is, of course, a big part dedicated to climate change and climate regulation. But there is one report utterly dedicated to disease regulation. So this is a report from almost more than 10 years. If you go to the page 22 of the report on ecosystem on human health, the first version, you have one of the box. It's a very big report with more than with 100 page, but page 22, you have this box about biodiversity, can biodiversity regulate infectious disease. And if you go to the examples they give, there is a kind of coronavirus. It's because it was the first coronavirus in China in 2003. And they wrote in this report just 1 year after that probably the first coronavirus appeared because of the consumption of wild animal meat in China. And in the other page of the report, they said that there is and you know probability of a new appearance of SWAS in the next decade. So they make a good prediction, and they give a prediction for each for many disease. They put the causes and the probability of new occurrence on the probability in what continent this disease uh, could be appear because of a lack of ecosystem services. So I want to say good job, but we will discuss this later. But apparently, no one take care of this. In my case, I read this report many years ago, so I read this page, and so in some aspects, I will be. I know that it was possible that we have a global pandemic because of a coronavirus, but like many people that read this report, I did not really take this in consideration in my life, and it's an important aspect we can discuss why this report, why no one seriously take care about all of these papers in about ecosystem services. But I just close these aspects to go back to the question of monetization of ecosystem services. Um, the idea, as I said, is some economists says we didn't care about ecosystem services because we didn't know, we didn't realize how much money they give us, how much is big the contribution to the global wealth. So there was attempts to evaluate, to assess this economic value. And this idea is very old. In fact, it goes back to the 50s. One of a very famous ecologist, Howard Odum, one of the main ecologists of the century, um, he had this project and he tried to make his project is not exactly the actual the current project. What he tried, what he proposed is to replace the dollar by an energetical unit or some ecological unit. He want to change the money. He have a new kind of new theory of currency, and he wants that we use a currency not based on gold but based on ecosystem production, something very strong and complex. I will not have time to expose this, but it's very interesting. But what people in environmental economy propose today is not this. Is not to build a new currency based on ecosystem production. What they propose is something very simple. It's to evaluate, to assess how much money ecosystem give to humanity each year. So a very important paper, a turning point in this discussion, is this paper from Constanza and Hall in Nature in 1985. And there's a lot of people, not so much, but a lot of famous people in ecology who wrote this paper, and they make an assessment. So the question is how much nature gives us by year, and the answer is something like, and this is very strange, but they say that the value of all the services given to humanity by ecosystems by year is between 16 and 54 trillions dollars per year. So the first common sense remark that we can make is there is a huge uncertainty on the measurement. If I estimate the how say it all of the production of France in 1 year, and I said it's between one value on 4 times this value, I will not be a good economist. If you see the national statistics, there is not this kind of uncertainty on the value.
Victor,
Yes.
5 minutes, okay? Can you, because it's 25 minutes to talk, so to have half an hour discussion.
Okay, I have to speed up.
Speed up, yeah.
Okay. So it's what I said. There is a big uncertainty on the value, and if you go to more recent studies, there's it's a big problem. The methodology, I will give two examples, how they calculate the value of pollination provided, the value of pollination provided to humanity by bees on wild pollinators. So they just calculate the cost of pollination if it will be made by human hand, and more specifically by some workers of China or India or this kind of poor countries. Even if it was poor countries workers who do by hand pollination, it would be something like 200 billions of dollars by year. But you see, there is for each calculate an uncertainty that is huge. If you go to the market, you want to have a precise price for what you buy, or not this kind of variation. I will go on this. I will directly go to a more interesting case. They make also a calculation for the recreative services of a forest. And it's very simple. They ask people, how much are you willing to pay to go in a forest? So the value of 1 kilometers of walk in a forest is around $2. And of course, we have, if we make if we want to be very precise, we can make a very strong objection. The slide doesn't work. Is the case of the forest you go is a forest where the worker is not nobody, is a painter, and he produce some paintings like Monet did with a value of millions of dollars. So of course, if you want to integrate all the parameters, all of the production of that are based on nature, you see it's very hard to have a good estimation. So this is my first claim. We can make calculation, but the measure is very fuzzy, and it's a big problem. And I try to go more fast. So that's how it works. And the question is, for what? Why do this? Why do make this kind of calculation? I think the first answer could be political rhetorics, to impress people, to convince them to change their practices if they realize that ecosystems are so much useful for us. This didn't work at all, basically because the great environmental non-governmental organizations like Greenpeace, Friends of the Earth, and so on doesn't want this kind of thinking. They are not anthropocentric. They think that nature should be a respect for itself, and they didn't work. But what is interesting that major countries don't care of these works, even if it was funded by international governmental organization. So why it didn't work with governments? I will just go on this, what is in French. Basically, there is one attempt, one country try to make a calculation. It was Ecuador. Ecuador proposed to the international community to receive a payment if they didn't burn a part of Amazonia to have petrol, oil. But what happened? It was no one was ready to pay Equator except the European Union, who were ready to give a very small amount of money. So this kind of negotiation didn't success. And there is one thing that some countries could pay other countries to protect ecosystems, but even inside one country, no country try to estimate the value of its own natural capital. And if we want to make a sustainable policy, we have to have an estimation of the sustainability. And the most simple criteria is to say that we will not decrease our natural capital, or we will not decrease the sum of the natural capital and the human capital. But no country makes this kind of calculation. No important country, only small countries like Ecuador and this kind. And for example, European Union doesn't make this kind of estimation. So when we speak about sustainable development, it's just words, and no one seriously try to make this. As I said in my slide, it's just a very huge university discussion, but without any political effect. And just to finish on this, the third use of this is, of course, produce a market of natural assets. So there is one example. There are several examples. One example is a carbon market in Europe, in the European Union. It was a big failure, and I think I have no time to explain exactly why. But you have already a part of my of my argument is, of course, if you don't know exactly what is the value that you buy or sell, it could not be an efficient market. And if you want to precise the price, if you want to make a better estimation of the price of natural assets, it will cost a lot in studies, in economical and ecological studies. And so you will increase what we call the transaction cost. So if it costs a lot to determine the price of the products, it's not a good market. And there is also, just I finish on this, an ethical argument. If one day we succeed to estimate correctly the value of the services that produce one ecosystem, it probably means that this ecosystem is strongly individuate, and so we can precisely study its ecological functions and its interaction with society. So in this case, it will look like an organism. It's very hard to explain, but more you are able to assess the health of an ecosystem on its value, more it looks like a moral passion, something that we should care because you have individual life. So there is both practical and political and ethical arguments against the commodification. And just to finish, I didn't believe, first, to summarize, I think it's not absurd to calculate the monetary value of ecosystem services. Just there is too much uncertainty to make a market. But it could be useful. For example, what proposed Equator to other countries in the world was not stupid. And they propose a price not according to the value of oil, but according to the value of the services that produce Amazonia. So there is a way to make some kind of ecosystem services payment without market, without making a commodification. And it's a kind of debate between what we call environmental economy and what we could call an ecological economy. that is not just putting price for commodification, but it's integrating the ecological aspects of societies inside the economy. I think I'm good in the time, no?
Thank you. No, it was a little bit later, but it's not so much. So thank you, Victor. Antoine, you want to start?
Yes.
Maybe Pablo, you have to switch, or it's Victor who has to switch.
Victor has to give me back the.
Is it? I stop the sharing and I have to give you how I said how I can do.
Okay, so just leave and then you connect
Okay,
back.
I leave.
That's the.
So goodbye.
The stupid way of doing that, but efficient. Okay, so it should be okay for you.
Okay, I think it's good.
Yep.
Okay, so first I want to thank Fabrizio and Pablo Jensen for giving me the opportunity to present my research on forest scientists and futures. So this talk is based on my PhD thesis in sociology, in which I studied how French forest scientists are forecasting and anticipating forest future in order to take actions against climate change and in order to adapt forests to it. So these are exploratory considerations, especially regarding on how scientists are understanding forest ecosystem complexity. So feel free to comment my talk. So in my PhD, I thought to answer to the following questions. How do forest scientists forecast and anticipate forest futures? How do their modeling practices shape current and future forest management? And why do forest scientists hold various and contradictory visions of forest futures? So to answer these questions, I've conducted a sociological inquiry into French forest research laboratories. So with semi-structures interviews with forest modelers, backed up with ethnographic observations. I also studied two forest knowledge infrastructures, a modeling platform, CAPSIS. CAPSIS is the name of a computer-aided projection of strategies in silviculture, and the network, the forest monitoring network Renécophore. In French, it's called Réseau national de suivi à long terme des écosystèmes forestiers, a national network for long-term monitoring and forest ecosystem. And I also propose an historical study of how forest research has evolved since the 19th century. So during the interviews, what struck me was that forest scientists did not share the same ideas regarding the technologies, the knowledge and the scientific approaches to be developed and financed to improve our understanding on forest dynamics and functioning, and to foresee how climate change will impact forests. So I noticed that forest scientists hold different views about forest. That is to say, what is a forest, how to understand forest dynamics and forest ecosystem complexity. That is to say, is it predictable or unpredictable? Will climate change have disruptive effects? And these visions depended on the scientists' academic disciplines and academic trajectory. So I also consider that when scientists talk about knowledge and technology that should be founded to improve our understanding of forest. These thoughts, this talk are not just epistemological thoughts, but political ones. They put forward what matters for forest research and for their own scientific practices. And so this idea of this political interpretation of this epistemological thoughts is in line with the so-called new political sociology of science, which examines how scientists are struggling to influence research agendas. So forest futures visions held by scientists encompass a certain understanding of what a forest is, of what technologies and knowledge matters, and of how forests should be managed to adapt to climate change. So for me, the notion of epistemic commitment was a good theoretical and methodological frame to study this question. That is to say, to understand how to understand the fact that forest scientists hold various visions of forest futures. So forest futures visions articulate a way of preempting climate change, as well as a set of actions to be taken to ensure that the desirable futures occur and to avoid threatening ones. So because of their scientific and social trajectory, their involvement in forest management, and their understanding of the science that matters, and also of how they are understanding what futures and forest are, forest scientists subscribe to one of the three visions of forest futures. So these all elements are what I call epistemic commitment, and the three visions of forest futures are the following: the risky future, monitoring, anticipating, and managing forests as technopolitical devices to reduce climate change; the disruptive future, of impacts of climate change, of global change on forests. Forests are here considered as nonlinear and stochastic ecosystems; and the historicized future of forests, which are a result of historical processes and accidents with long-term dynamics. So I will describe here the three visions according to the following outline. First, I will give a few words of general description of these visions, and also specify what actors and institutions are holding this vision. Then I consider the four elements that I hear, which are structuring the visions of forest futures. First, a way of conceiving the temporality of the future and its relations to the past and the present. Is will the future be linear or disruptive, predictable or unpredictable? A conception of forest to be known and the ideal forest to be shaped. So this entails both a knowledge project and action project. A commitment to knowledge and technologies that need to be developed and founded to better understand and manage a forest, and an ethos of anticipation. How forest scientists perceive their way of doing science, both as a creation of objective knowledge and as a profession and cultural, social, and technical practices. So in the first vision is called the risky future. So within the risky future, scientists aim to monitor, to forecast, and to act in order to reduce future risks that are threatening forests. And these risks are considered both as a threat, but also as an opportunity to develop what I have called forest infrastructures, that is to say, enhanced the forest function as a carbon sinks or wood energy to struggle climate change. And here, scientists are sharing an ethos of trust towards models, increasing computing power and new technologies for data collection, as remote sensing or the LiDAR technology, and new technologies for data processing as big data. Here, the scientific actors and institutions which hold this vision of forest are NFO, French National Forest Office engineers, the Academy of Agriculture, the Ministry of Agriculture, also forest modelers whose work is at the interface of forest research and forest management, also statisticians and remote sensing scientists involved in modeling and simulation projects, and forest monitoring networks as Forest Hills Department. So, as I said, here the key notion is risk. Many risks are threatening forest futures, like increasing temperatures, droughts, wildfires, new pathogens. And scientists have thus to identify these risks in order to contain them. To this end, forest scientists and experts are relying on socio-technical arrangements designed to monitor French forests, like simulation models backed up with extensive database fueled by forest monitoring network as RENECO4 or the Forest Hills Department. Here also new technologies such as remote sensing or modeling hold the promise to better know the risk and therefore to mitigate it. However, risks are also understood as opportunities for actions, such as the implementation of new forest policies centered on forest functioning to struggle and to adapt to climate change. Therefore, forests are not only threatened by climate change, they also provide ways to mitigating it, like wood energy or carbon sinks, or provide ways to adapt to it, like actions such as assisted migration of species or non-native species introduction. So what I called forest infrastructures is forests that store carbons and produce energy, and they are considered as a key element in climate change mitigation and adaptation. So here risks have here a dual nature, a dual signification, both as threats and hazards that need to be contained, and opportunities to implement new technologies and to strengthen forest ecosystem services such as carbon sink. So forests are therefore understood as technico-political devices, a way of governing environment in line with studies that have already analyzed the political dimensions of the datafication process, for example. Here, forests transformed into data as globally governable. Risk is therefore understood as a compass helping decision-making amid uncertainty. And here the risky future is in line with the security paradigm tied to a particular understanding of complexity, the complex adaptative system, as described by the Australian philosopher of science, Jeremy Walker. Forests are socio-ecological resilient ecosystems, and therefore adaptation to climate change is technically possible. Therefore, here new technologies play a crucial role in forest knowledge and management, such as LiDAR technology, which allows scientists to gain more precise information on forests. And this information and data will fuel model simulation to anticipate forest future. And then here the remote sensing promises better knowledge of forest are in line with the promises of environmental monitoring, which seek to transform forest into data to better manage it. So modeling and simulation and the development of computing power are really are the cornerstone of this first vision of the future. And here, scientists and actors which hold this vision have trust the idea that forests could help us struggle climate change, and that a new technology could help us to have a better understanding of forest dynamics, and then to have a better forest management. However, this vision, this trust toward the new technologies is criticized by the other actors of this scientific community, as I will explain it later. So the risky future is neither an apocalyptic nor a catastrophic future, but quite the opposite. This future thus contains a certain optimism, and the discourse about the risks affecting forests is backed up with an optimistic discourse about new technologies and the need for reorganizing forest management and ownership. So the second vision is called the Descriptive Future. And within the Descriptive Future, actors, scientists think that improving our fundamental knowledge of forest ecosystem is the key issue to understand and to anticipate climate change effects on forests. For this reason, forest scientists should focus on uncovering ecosystem processes under these unknown conditions, and thus focus on linking both experimental and modeling approaches. So scientific actors and institutions which are holding these visions are forest ecologists and forest ecophysiologists working at the CEF, le Centre d'écologie fonctionnelle et évolutive in Montpellier, or in INRAE. Also experimental or observational knowledge infrastructures as the Puy-Chabon site, as I will show you later. So unlike the risky future, new technologies are not meant to be at the core of forest research. Here, forest scientists are sharing an ethos of giving up anticipative practices. For them, there are currently too many uncertainties about forest futures dynamics to act now on the basis of model forecasts. So these forest scientists criticize the long-term timescale projections like species distribution models. According to the following idea, scientists would be encouraged by funding agencies to produce this kind of maps, despite their scientific irrelevance, since the future they seek to anticipate will differ essentially from what is known today. So I put it here the species distributions models. The first one is the current pitch distribution model, and the second one is what we forecast, how we forecast the pitch distribution will be in the future at in 200. So these types of modeling were very success in past 10 years, but attract also a lot of criticism from the scientific community.
Antoine, 5 minutes left, okay? Thank you.
Okay. So here they hold criticism against new technologies, and because for them climate change complexity is unreachable through even more precise simulation models, and so we have to improving forest ecosystem fundamental knowledge. To do so, they want to link a modeling approach with experimental devices like the Puy-Chabon experimentation. It is an exclusion, a rain exclusion experimentation, both total and partial. That is to say, they put on a forest this platform in order to reduce rainfall, and then to observe how trees are functioning under those circumstances. We can also talk about econtrons. We'll simulate under climate change conditions the growth of plants. So facing the disruptive future, these scientists decide to give up anticipating the effects of climate change on forests, or to slow down their modeling activities, to return to fieldwork and to experimentations. So the third visions of the future is called the historicized future, and within this vision, scientists consider forests as socio-ecological and historicized environments. So to anticipate forest futures, we first need a precise knowledge of forest past dynamics based on long-term data. They thus emphasize interdisciplinary approaches so as to rebuild forest socio-historical trends. It's what we call the forest memory. Here, forest memory refers here to the fact that forests are complex ecosystems in which initial conditions are crucial to understand the system evolution. For example, ancient Gallo-Roman land uses influence current forest biodiversity. Here, the forest scientists are sharing an ethos of responsibility. That is to say, despite the many uncertainties, forest scientists should try to anticipate future trends of forest. And actors that are holding this vision are forest modelers interested in forest dynamics and forest growth, and forest ecologists interested in forest biodiversity and forest history. So for this here, in order to understand the future of forest, we first have to understand the past of this of the forest. So they they try to collect past long-term data in forest research and management data in order to reconstruct forest past trends. And they also, for them, ecological or ecophysiological or statistical approaches are not sufficient to know forest past trends. Scientific promote, therefore, like I said, interdisciplinary work, and they are also these scientists exalt a better knowledge of forest past and advocate that this approach be put on the core of forest research agenda, despite the fact that they criticize the fact that new technologies are at the core now of forest management and forest science. And in the difference of scientists who hold the first vision, the descriptive future visions, they think that ecologist experts should publicly speak about their expertise and how they are forecasting forest futures in order to help decision making, to help stakeholders to have a better management decisions. So maybe I will stop here if it's okay. I don't know.
Thank you, Antoine. Thank you, Pablo. I will start with a couple of questions for both. Okay.
Okay.
Thank you both. I will start with Victor and then with Antoine, and then you will be able to answer these questions. And then if people want to ask questions in the chat, please go ahead. Victor, I know your work, so I do know that complexity is in your work too, but in your presentation today, certainly for reasons of time, it wasn't so much visible. So I will ask you two questions that will make you possible to make explicit these points. So the first question is, what is the influence of cybernetics? Cybernetics being one of the complexity theories that we have discussed in this seminar on ecology. So the influence of cybernetics on ecology through Odum, because I think that Odum was basically a cybernetician. Correct me if I'm wrong. And the second question is, what is your argument from complexity to claim your thesis? Because when we talked about it on the telephone, you explained me that complexity is an argument that you use in order to claim the differentiation between monetization and commodification of systems, of ecosystems. And for Antoine, I will start by giving a sort of a small interpretation of the three communities. Sorry. So basically, the risky future, so the first future, is the engineering view, which is reductionist and linear, and which thinks that for every problem there is a solution. This is the way I would interpret it. Then, of course, you will tell me if I'm wrong. The other two are the most it seems to me that the other two are the most respectful of complexity. But while the disruptive future draws from chaos theory, for example, when they talk about sensitivity to initial conditions, and this make them lead to an attitude of renouncement of predicting the future, the historicized future seems to be the least reductionist to me, and the most respectful of complexity without losing in proactivity. So the first question is, am I correct in this interpretation? And secondly, could you say more about what leads the disruptive future to a renouncement attitude? Because I used if I if I may take 30 seconds more, I use the same concept of epistemic engagement, commitment, sorry, in one of my articles, precisely to sort of give a small cartography of the groups within complexity sciences. And precisely, there are people from complexity which, because they take so much inspiration from chaos theory, they renounce, they give it up to have. So I wanted to know exactly what are the influences, what are the epistemological, the political reasons that bring them to do that. So to make a parallel with what I've seen in my fieldwork. And the second question, shorter, is can you tell us more about philosopher Jeremy Walker, who talks about complex adaptive systems that you quickly mentioned, but I think we are more than one in wanting to know a little bit more about that. That's it, and thank you in advance, Victor.
Okay, I start. There's two questions, one historical and one more theoretical. I think I will answer first the theoretical question. Why is the complexity in my talk? In fact, yes, it was a skip part. The idea is basically there is a big discussion on the relation between biodiversity and ecosystem functionality. And there is this idea, the discussion is about the idea that more diverse is the ecosystem, more you have diversity, more is stable and resilient. But in fact, there is no linear relationship between the species richness and the ecosystem functionality. So if we want to assess the value on an ecosystem, we have to have a parameter. And because there is first an uncertainty on the relation about the relation between the ecological parameters, there is two kinds of uncertainty. There is an uncertainty inside ecology. You cannot predict if we divide by 2 the biodiversity of this ecosystem, this will reduce this function to this level. And there is another uncertainty, is the complexity of the relation between ecosystem function and ecosystem services for human. So you are not sure, it's very hard to predict if you agree what Antoine calls the nonlinear system view. If you agree on this view that it's very hard to predict the trajectory of forest, it's harder to estimate the trajectory of the value of the economic value of the function of a forest, because you're not sure what will be the function of the forest in 10 years, and you want to know the value, the economical value of this ecological value that you didn't know very well. So there is kind of double uncertainty. Is it clear, my answer, or not?
I think so.
Yes. And so for the historical part, what is the importance of cybernetics for ecology, for ecosystem ecology more specifically? It was very important. It's more the work, I think, of von Bertalanffy, who influenced them. But in fact, it's not only the use of mathematical system dynamics theory. The only facts to use physics, the only facts to use thermodynamical tools to calculate the flow of energy, or to make some kind of assumption about the entropy of forest. It was a big evolution, because before ecology, what we call ecology in the beginning of the 20th centuries, it was something with no maths at all, and no, it was just studying some species distributions very qualitatively, and to understand the relation between species, but without no modelization. So the only fact of doing modelization, what is now old, was a big change, and the people who did this change, people like Lindemann and Odum, was people with a good understanding of cybernetic.
Okay, but then you say that von Bertalanffy exerted more impact on ecology than cybernetics. So that's what you say.
I think that these people, like Odum, there is two Odums, to be precise. There is Eugène Odum and his brother Thomas Odum, who wrote together a book, was the textbook for ecology in USA during more than 1 decade, a very important book, and with a lot of new editions. But what I said that even if they use only something that was very simple physics for ecology, it will be a great change for ecology. But in fact, they not just do what I show you, just calculate a flow of matters. They have a discussion about all we know, the fact that there is a sensibility to initial condition, chaotic system.
Feedbacks.
All of this
Yeah.
was put together, and I'm not sure exactly what aspects of theoretical physics or mathematics were more important, but I know that the name of Bertalanffy is very often mentioned in this book.
Thank you. Antoine, maybe.
Yes. So thank you for your questions, Fabrizio. To answer your first questions, yes, you good interpret what I meant with this three vision, and how you see the complexity theory of the complexity visions in this. Yes, the first vision, the risky futures, thinks that we can adapt to climate change with and through new technologies, and we can improve our understanding of this phenomenon. And yes, to answer your question and why I've put forward the idea of an ethos of giving up anticipative practices, is that for me, what I've called this ethos of anticipation is not just an ethos, it's not the ethos of scientific practices in general, but it's really focused on anticipation and how scientists are consider anticipation through modeling and simulation approaches. And so the actors, the scientists that I have put in this category of disruptive futures, all of them hold very negative comments, criticism against model and modeling practices. Not modeling practices in general, but the fact that since maybe 20 years, modeling practices are at the core of forest research, and that it's almost attracting all the funds, all the money, and that if you want to fund it, a scientific project, you have to have with you modelers. We will make this. We'll run simulation models with future scenario and climatic scenario. So they all, to me, very hard criticism against the fact that models are central in forest research, despite the fact that it's doesn't help us to improve our knowledge. For them, if we want to improve knowledge, we have to get back to fieldwork, to experimentation, and to establish a dialogue, a link between modeling practices and experimental practices.
So this is the disruptive future you're talking about. To sum it up, just what you said, basically they do computer modeling even if they don't believe it too much in it, just because it's a sort of a zeitgeist of the public fundings.
Yes, of course. And also these visions, I do not precise it, but these visions are not, people and scientists are not tied forever with these visions. They can move to the first, to the second, or to the third visions, depending on the scientific projects, depending also on scientific arenas. Are they willing to play the game of be founded, so to play the model game and the anticipative game, despite the fact that they deeply think that we cannot have a better knowledge of the future with modelization. So that's why I put this ethos of giving up anticipative practices at the contrasting to the historicized futures, who hold a better view of models. They think that models can help us to anticipate climate change, and for them models are key tools in their practices. But they think that it's not new technologies of data collection, but to investigate into long-term and past data, as forest management have, like, I don't know, data about trees like 100 or 150 years. So they think that we should focus and fund this project. So that's for the first question. And to the second questions, so I don't know if I will good answer, but I will tell you what I had in mind. Is that I try to fit my presentation with the thematic of this seminar, so complexity theories. And I think in my presentation and also in my reflections, complexity theory was not at the core, and maybe hidden in the data. So I try to make it visible, and with all the I don't know, with all the lack of knowledge I have on complex theory. So for me, in his book, Jeremy Walker, he tied the idea of Oring, of this complex adaptative system, with other general theories, and what he has called the security paradigm, or the preparedness paradigm. That is to say that in security studies, or in security, also like post 9/11, we seek to anticipate phenomena that are unpredictable, that are difficult to predict, and therefore we have to be prepared of worst case scenarios, and new technologies in this perspective can give us a clue and key to understand what could be happen. And so I thought that there are some relations, some points of common of this view of the risky future. That is to say, yes, many risks are threatening forests. We have the power to anticipate it, despite the fact that some are disruptive, some are unpredictable, and so on. And so I thought that the two arguments were similar in some way, and so I refer to this conception of complex adaptative system, also with the idea that forests are resilient enough to adapt to climate change, and so it's also like an optimist view of what climate change effects will be. I don't know if it's.
Yeah. I think it's very interesting. Pablo, you have questions? Nobody on the chat has questions?
No, okay. I have a naive question for Victor. You said that it's difficult to put a market price on carbon because it's or on biodiversity because it's difficult to compute the value. But I thought my naive lectures on IAC suggested that markets are a mechanism to put prices, to find the prices. So why, I mean, doesn't market just work out to find the price? Maybe because no one wants, I mean, there is no demand and offer because there is no demand for carbon, or I mean, what's the problem there? Something I don't understand.
Okay. In fact, there is several markets. For example, the carbon market exists and it's a failure. And there is a lot of papers about this. Why the European carbon market failed. He failed. What I said when he failed, it means that the price have a lot of fluctuation. And a good market is not a market with price changing every day. If you go to buy a baguette of bread, you don't expect the price to be between 50 cents and 2 euros, and to be 50 cents one day and 3 euros tomorrow, and again 1 euro the day after. So there is an factual aspect. We observe that no one succeed to make a market of ecological assets work. And in fact, carbon is the most easy case. It's very easy to estimate the pollution, the absorption of carbon of forest. It's very easy to estimate the emission of carbon of humanity. And we have good models of the climate trajectory according to the human emission. In fact, the case of the carbon is the more simple case with a low complexity. And if you go for other parameters like disease regulation, it's very hard to understand what will be the cost for humanities in the 50 years we will come if we destroy half of the Amazonia on the aspects of new disease. And it's what they try to do in the Millennium ecosystem assessment. They try to put probabilities of occurrence of new disease according to the destruction of each biome on the world. And they make a list for each continent what is the ecosystems who hold a regulation of this disease and what is the severity of the disease. And they make something with some plus sign with the severity of the disease, the probability of occurrence of the pandemic, and an estimation part of the world by part of the world. And this is useful, but there is too much uncertainty to be able to put a price, because you can put a price, but the price will fluctuate a lot, and it's not what we want. And if you don't want a fluctuation, there is only one way: it's to have a more specific unit. For example, biodiversity is not a good unit. First, it's very hard to estimate biodiversity. It is a number of species, genetic diversity, a diversity of ecosystems. But okay, some people measure biodiversity. There's some kind of measure, but it's a very imprecise proxy for predicting the services that give ecosystem. So you have to go to more specific parameters, but more the parameters is precise, less the market will be big. If you have a market for carbon, a market for azote, a market, you have it will be a lot of markets. On if we want to understand very well this stuff, the other market, not the carbon market, is the compensation market, is the grassland compensation market in USA. The idea is you have to avoid to destroy a grassland or generally an ecosystem. If you destroy it, you could buy another one. You can destroy what kind of ecosystem. You destroy the grassland water ecosystem in Florida, and you pay to develop another one. I don't know, California. But in fact, it's very hard to understand how to make the compensation. What units we should have. For example, maybe in Florida, it's more efficient than in California for one outcome, and it's not for another. And it's very hard to make a compensation to know to make a, how to say to have a common value for the assessment of ecosystems. I'm not sure if I'm very clear, but to give just one example, when it's worked well, it's the case of fire. It's easy to predict how much a forest protect against fire, and it's pretty easy to estimate how much money we will lose according to the size of the fire. There is some kind of linear relationship. So for some specific services, it's possible to make a good estimation, but for many services, if you go to aesthetic services, how much money is it? How much is the value of the ecosystem services for the production of art? It's very hard to understand this, and it's very hard to understand how, if you destroy this forest, how much we will lose in art. Even if you can agree that there is a connection, there's a relation, it's very hard to make mathematical models and to have a good measurement of the parameters. So for some local case like carbon, it could work. In fact, it doesn't work, but it could be in theory. Maybe for fire, it's possible, but if you go to art or if you go to disease regulation, it's very hard to, for example, the actual pandemic cost a lot to humanity, and it's in part because of degradation of forest. But it was not possible to predict this. Even if some people predicted, you have a prediction of this. It's very hard to make a future prediction. How much humanity will lost because of the degradation of forest in apparition of next coronavirus.
It's impossible to even quantify what the pandemics has destroyed of the economy today, even once it happened. So it's even more impossible to predict something like that.
It's possible, but it's possible with a huge uncertainty. If I said the baguette of bread is between €1 and €10, you said, what is this? It's not a good estimation.
Yeah. It's a non-equilibrium market, which is also almost an euphemism. I shared in the chat the thesis of a friend who worked on ecosystemic compensation.
Yeah. Bon, okay, and I shared some advertising for
Yeah,
next Monday seminar that is related to this series of seminars on complexity, and it's about digital tools to govern complex societies with Dominique Pestre at HESS and Matthias Schemmel from Max Planck Institute. So don't miss that.
So our seminar ends up today, but this one is another one about complexity and governance in a digital world, right?
Yeah. Yep.
Thank you.
Okay,
thank
so
you, everybody.
Thanks a lot,
Thank you.
Victor. Thanks a lot, Antoine. And well, see you on another seminar, probably. Okay, maybe next Monday. Okay.
See you.
Yeah,
Bye-bye.
thank you very much.
Bye-bye.
Bye.
Bye-bye, everyone.
Bye-bye.